Hello and welcome back. This is Greg French. Today we're going to be looking at computer repair training, hardware, lesson 1, part 2. Also on here you can see the computer repair training plus.com. This is a website where you can find some additional resources for the material that we're covering. You might check that out if you're interested. Motherboard. We're going to be looking at the motherboard today. This is the main board, the largest circuit board in the computer. It contains the CPU, memory, north bridge, south bridge, a lot of other parts. We'll be talking about those parts. The main categories on the motherboard, we have the processing, the CPU, temporary storage, the RAM, communications, and power. We'll be discussing those. Everything, it says all communicate with the CPU. Everything on the motherboard, everything connected to the computer, all has to communicate with the CPU. CPU is the central processing unit. Every piece of data that's generated has to be processed by the CPU. Peripherals. The peripherals are devices that are connected to the computer and they're linked via a cable. So you have some kind of a data cable that connects devices to the computer, such as the keyboard has a connection, mouse has a connection, monitor has a connection. You might also have a modem or a cable for a network. That also is a peripheral device connected to the computer. Here's an example of a motherboard. You can see there's quite a few components on the motherboard. Either on or off the motherboard, again, everything has to communicate to the CPU. CPU has to process all the data. Here's a side view of the motherboard with some of the I/O connections. This is an ATX style motherboard. Again, here you can see here, this is the eSATA. These are external SATA or external serial drives. The new technology, 3 gigabits per second. Also we have USB 2. We have 8 ports here. Also we have on the top of this we have a FireWire connection and a gigabit LAN. A gigabit LAN is a billion bits per second LAN connection. Audio, we have a little optical audio connection here and your other typical audio ports. CPU and chipset. CPU performs the data processing. It processes all the data and the instructions. Now the chipset, it's microchips. They control this data flow. We'll be talking about the chipsets. Very important because they do manage the flow of the data on the motherboard. Manufacturers of CPUs and chipsets, Intel being the major number one. 80% of the market is controlled by Intel. AMD is a good competitor. We've enjoyed having them keeping Intel on their toes. We also have VIA, SIS, and Cyrix. Here's showing the chipsets. We've got the north bridge right here, and then we have a south bridge. The north bridge controls the memory to the CPU, also the video card. So the north bridge has to operate very quickly. Otherwise, we can have a bottleneck in our computer, so we have to have fast RAM and a fast video card in order to keep our computer running at its top speed. There's also a south bridge down here. Now, the south bridge can control everything else. Your PCI connectors here, any SATA or any hard drive connections, also any FireWire, mouse port connections, keyboard connections. So everything else goes through here. Here's a diagram. CPU, north bridge stands for, NB stands for north bridge. It's also called the memory controller. Intel just recently moved their memory controller onto their CPU with the Core i7. The video and RAM are normally controlled with the north bridge. And then the south bridge, again, controls everything else. Now, this is a diagram I've drawn up, and I expect my students to be able to draw it too. So you might take notes on this, because I'm going to ask you to draw it. Storage devices. Primary storage. Primary storage is temporary. It's RAM. Computer needs a lot of RAM in order to push data and instructions through it. The RAM is usually very fast. Not quite as fast as the CPU, but much faster than our secondary storage device, the hard drive. The RAM today can push gigabits of data, where the hard drives are still constrained to about 100 megabits, considerably slower. This is a picture of Corsair RAM module. RAM again, temporary holding. These have a slot on here for connecting them to the motherboard. They're fairly easy to connect. They just push straight down to the motherboard today. It says RAM memory is a temporary place to hold instructions and data, while the CPU does process both. Primary storage. RAM, random access memory. It's temporary. 3 types. We have DIMM, RIM, and SIMMs. DIMMs are pretty much all we see today. There's dual inline memory modules, DDR1, DDR2, and now DDR3. It's getting faster and faster because the CPUs demand faster memory. RAM is volatile. This means when the power is turned off, that memory goes away. We need a hard drive or some kind of a storage device in order to be a permanent memory. ROM, this is read-only memory, non-volatile. That's on the motherboard to help the computer start up. We need some kind of instructions that the computer can run when it first turns on. And we'll be talking about that power on self-test that is performed by the ROM. Here's a picture of some memory slots. We've got actually 2 memory slots here. This would be a dual channel memory. Anytime you have dual channel, to utilize it, you need to split your memory across both. If we were going to put 2 gigs of RAM on here, we would want to put 1 gig on one slot and then 1 gig on the other slot, not 2 on one. Otherwise, you don't get the full benefit of your dual channel. The dual channel will increase the ability for the memory to be read by the CPU considerably because we have 2 separate channels. Secondary storage, again, the hard drive. Disks that rotate at high speed, they're mechanical devices, old, antiquated technology being replaced by today's new digital drives. ATA is one of the technologies used. There's also newer technology called SATA. Parallel ATA accommodates up to 4 IDE devices. This is an example of an older IDE drive. This has 6 platters. Today, most of the drives only have 2 platters. This has the cover removed. Normally, you don't want to remove the cover and expose this because dirt or contamination will destroy the drive. Here you see an IDE cable, a 40-pin cable, being connected to a hard drive and to a CD-ROM. Now, a lot of these cables are now 80-pin cables. They look pretty much the same. You still have 40-pin connectors, but they allow the data to be driven a little bit faster. Only 1 connection on the motherboard here. A lot of motherboards have 2 connections so that we can put 4 devices on the motherboard, on the computer. Secondary storage continued. The new types of hard drives, the serial ATA, outperform the IDEs about 2 times. They're considerably faster. IDEs run at about 50 megabits per second or megabytes per second. The serials run at about 100. IDE devices, hard drive, zip drive, CD-ROM, quite a few things have been developed to connect to the IDE. Floppy drive, a small device. You don't see them on a lot of the computers today. Doesn't hold much data, only 1.44 megabytes. CD-ROMs, compact disc, we do see a lot of those today. We need those to run our DVDs. Here's a 34-pin floppy drive connector. You can find them sometimes on the motherboard. In review, motherboard, CPU, chipsets, memory. Need to remember that the chipsets are there to support the CPU. We have a north bridge or memory controller that supports the RAM memory, and the video card, the south bridge, supports everything else on the computer. Primary storage, remember this, is the RAM. Secondary storage is the hard drive. Activities, I want you to draw the CPU, RAM, video, north bridge diagram. I want you to show me how that is set up. It's very important to have that good understanding of that. It's a good question that I would ask during an interview. I want you to do lab 1.2, and I want you to identify the computer parts on that motherboard and also the parts on the computer. I want you to answer those and then turn those in. That's it for now. Thank you very much for your time.